Hello, everyone. I hope you guys had a very relaxing spring break. I know I gave you 2 more free response questions to work on, and those solutions will be coming soon. Again, as always, please let me know if you have any questions along the way. The main idea here is for you guys to fully understand all the steps involved as it relates back to a lot of previous material and prepares you as best as possible for the AP exam that you guys will be taking. So I know I provided feedback and you guys did some corrections on these, but please follow along just to see and hear the explanations as far as also with the points that are involved here, but as far as what you can write out to ensure that you get the most points possible for each problem. So for 6a, we're given this differential equation and a slope field here. Just to go through each point, I know for a lot of the homework problems I was giving you, you could write the slopes next to it if like the entire row or column had that. In here, it's different because this contains both x and y. So just to go through slowly, there's really 2 points to score on this. One is to know when all the slopes are 0, and then the second point for indicating the slopes that are either positive or negative here. So what you can do is just write this out. For instance, let's start at the origin because that's the easiest point to calculate here. That dy over dx is going to equal 0 squared and then 0 minus 1. So 0 times anything is 0. So at any point where x is 0, we're going to have a horizontal tangent line, or the slope is going to be 0. So that's all along the y-axis here. And not only when x is 0, but when y is 1, because when y is 1, 1 minus 1 will give us 0. So I'm just writing this off to the side. At all points x, y, where x is 0 or y is 1, dy over dx is equal to 0. So that's also going to happen here at 1, 1 and negative 1, 1. So you could show the work off to the side, or just knowing when you go to substitute in a 1 up here for y minus 1. Now, actually, the second part I'm going to write out. So we get 1 point for indicating, not necessarily writing that off to the side, but just indicating that on the slope field itself. You get the other point, which is actually going to help us answer part B, is to know where the slopes are positive. So dy over dx is going to be positive for every xy. Let me even write that out. For all values x, y, where y is greater than 1, and because y is greater than 1 at 2 and 3 here on the y-axis, but x is 0 there, so we can't let x be 0. So we have to say where x is not equal to 0. So for a few of you that turned this in, and I kind of pointed out for part B, you did mention where y is greater than 1, but we also have to indicate something about the x values here, and that's where x is not equal to 0. So that's going to happen at 1, 2. So just to write this off to the side, at 1, 2, also at negative 1, 2, dy over dx is going to be 1 squared or negative 1 squared. I'll put this in here because both of them will give us a 1. And then we'll get a 2 minus 1. So this will give us a positive 1. So we have a slope of positive 1 here and here. At 1, 3, and also negative 1, 3, dy over dx is going to equal plus or minus 1 squared, and then 3 minus 1, so this will give us 2. So we have positive slopes there. So this is only worth 2 points. So even though we wrote this out here, we still get our second point as a combined from writing out where the slopes are positive and negative. So we'll say at all points x, y, where y is less than 1, and again, x is not equal to 0, dy over dx is negative. So right here at -1, 0, that would just give us, showing this up here, we'll do this at the top. So we'll say at plus or minus 1, 0, dy over dx is going to equal plus or minus 1 squared, and then 0 minus 1. So no matter what, we're going to get a -1 because this first value is going to be a +1, so that's going to equal -1 here. All right, so we get a total of 2 points for part A. All right, now we're actually going to use what I explained here in part A for part B. So this is just worth 1 point. So for parts A and B, we're at a total of 3 points so far. So it just says describe all points in the xy plane for which the slopes are positive. So here we would just say the slopes are positive. Again, we'll say for all points xy, where y is definitely greater than 1, because we saw what happened when y was equal to 1. We had horizontal tangent lines here, but we also have to say and where x is not equal to 0. All right, now for part C, we are asked to find a particular solution. So I have some of this work already written out. You get 1 point so far. So we're starting with the differential equation. You get 1 point right here for the separation of variables. You get 1 point there so far. And then to find the antiderivative is 2 points. So for parts A and B, and just the very beginning of part C, we're up to 6 points if we did all of this. And then even a 7th point here for the constant of integration. Now, even though I'm stressing this final part where we use the initial condition at the very end, if you don't really get it, it's not going to be a huge loss like the majority of the problem here. So we get a lot of the points just from beginning the problem. So writing this out, the integral, taking the integral of each part, and again, I stress when you write the integral, make sure this one, they were already there, but we want to make sure that we have the dy and the dx written in. A lot of times on the acceleration and velocity problems, we forget to write those in. All right, so the antiderivative of the left side gives us the natural log of the absolute value. It's very important to write this in here. The absolute value of y minus 1 plus a constant is going to equal x cubed over 3 is the antiderivative of x squared plus our second constant. We bring all of our constants to one side. And a lot of you are still doing good with this, but still leave the absolute values around. We're going to get e to the natural log of the absolute value of y minus 1 is equal to e to the x cubed over 3 plus c. So over here, now we have absolute value of y minus 1. We're going to separate this using the laws of exponents. So we get x cubed over 3 times e to the c. A lot of you are doing good with showing this, that becomes an a. So now we have a general equation still of absolute value of y minus 1 is equal to a, let me separate this here, times e to the x cubed over 3. So now this is where we separate this and we say, well, y minus 1 could equal, and in this case, yes, technically we could say plus or minus a times e to the x cubed over 3, and then we get y equals plus or minus a times e to the x cubed over 3 plus 1. But when we go to use the initial condition, we have to be very careful here. Don't use the plus or minus just yet. So you get 1 point for using the initial condition, which is f of 0 equals 3. Indicate only here. We're going to use just the positive. So y is going to equal a times e to the x cubed over 3. I'm going to work this out another way too, just to show you. Okay. Just to show you what would happen if we did use the negative a equation. So just to show you this here, we're going to get 3 is equal to a times e to the 0 really plus 1. So a is going to equal 2. So now this gives us our specific solution is that y equals 2 times e to the x cubed over 3 plus 1. If we used y equals the opposite of a times e to the x cubed over 3 plus 1, we would eventually get, using this here, 3 is equal to a, negative a, e to the 0 plus 1. So 2 is equal to negative a, which means a is equal to negative 2. But now if we go to substitute this back in to this equation right here, y is going to equal the opposite of negative 2 times e to the x cubed over 3 plus 1, which brings us back to y equals 2 times e to the x cubed over 3 plus 1. So these are always going to be the same, which is why we don't have to show it twice, so only show it once. You could still show this up here that y is equal to plus or minus, but again, the initial condition is going to dictate what that a value is. So you only have to do this once. You either pick the y is equal to the negative a or y is equal to positive a. So the other two equations, or the other 2 points really. So now we're going to get 1 point for solving for y. So we are at 6 points here, and then 3 points for parts A and B. They do have a note here that 0 points if y is not exponential, and a max of 3 out of 6 if there's no constant of integration, so that's very important. And then 0 out of 6 if you skipped over all of the separation of variables, which is difficult to do if you didn't, to try to figure out any other way to go through this. So it's almost going to guarantee that you do that separation of variables there. So there are all the 9 points for this problem. Let me know if you guys have any questions. If you did not do this problem yet, I'm going to give you a makeup problem to do for the points for this. Okay, so again, let me know if you guys have any questions.